Hello.
Hello and welcome to this construction domain session as part of the buildingSMART International Summit Marrakesh 2024. Thank you for joining. My name is Laura and I will be your moderator today. Today's session is titled Planning Progress Monitoring and Interactive openBIM Project Management Dashboard. The speaker for this session is Darko Yannick, CEO and co-founder of Textile Consulting. This session is scheduled to last 90 minutes, including time for question at the end. The session is being recorded and will be made available in the replay section of the event as soon as possible. Before I hand over to Darko, I would like to remind you that this is an hybrid event. For online attendees, your microphone will remain muted for the duration of the session. If you wish to make a comment or ask a question, please use the chat box in the control panel. For the attendee here in the room, please keep the background noise to a minimum, and if you wish to make a comment or ask a question, please raise your hand and use a microphone. I would like to bring to your attention that buildingSMART is committed to ensuring that participation in the development of the standards is unrestricted, and the process for their adoption is transparent, and standards that developed do not favor any particular provider and are open, non-binding, and accessible to all. Please take note of our antitrust code of conduct, and now we'd like to hand over to Darko.
Thank you, Laura. Hello, everyone. So I hope you can hear me now.
Yes.
Okay. So today I'm going to talk about basically how the openBIM standards can be integrated in overall BIM implementation of the project. Particularly, I will focus on phases related to construction part of the project, but I'm going to mention also several things related to the design phase, and maybe in the end mention a couple of things related to asset management and facility maintenance phase. So in this particular presentation, I'm going to show you a national football stadium case study. So this is currently the most important project, I would say, in the entire region. It has slightly more than 52,000 places for attendees. And it's one of the top three greenest stadiums in the world at the moment. So about Bexel, so here for a long time in this openBIM industry, 15 years in construction management, 19 in software development, and more than $500 billion of US dollars is the value of the projects where Bexel is used now. Here are some of our clients, and here are some of the projects. So from airports, football stadiums, data centers, railways, highways, bridges, factories, hospitals, and so on. And in terms of usage, as we believe that BIM can be implemented from in all phases of the project, and for all types of the project, we can see here that almost equally our users are using our technologies for infrastructure projects and for high-rise building projects. So I will now focus on this national football stadium case study. I will tell you what were the challenges and on the other side, the opportunities, what was achieved so far, and how actually openBIM was used in pre-construction and construction phase of the project. So today I'm going to mention several things what we believe is important for integrated project management. So one thing is, of course, to have a 3D visualization, which helps a lot. Then in this case, could be a quantity takeoffs. I will also briefly mention data checks, IDS, and some other interesting workflows. Then everything is included in the 4D, 5D integrated environment, and various what-if scenarios were produced in this case. And at the end, when the all analyses are done, look ahead plans and various things necessary for the field engineers to effectively execute the project were produced. They are on the regular basis sent to the site, and there are various, again, open BCF workflows and also open CD workflows where various document approvals are done, certification of executed works, and so on. Again, everything in openBIM environment. And for top managers, they can see always where the project is at the moment, earned value analysis, delay analysis, compensation analysis, some Monte Carlo analysis, so they can analyze the effectiveness of the project. So in this first part of the presentation, I'm going to focus on a 2-week period which happened in the last 2 weeks of April this year. And the task was very challenging. So basically only a pure BIM model was submitted by one very well-known design architects from Spain, FEMVIC, and they had already experience for the football stadiums for previous World Cup. But the model did not contain any information related to quantification, cost estimation, planning, scheduling, and so on. And the task was that in 2 weeks, the client wanted to see all beautiful simulations, resource analysis, quantity of materials, even a cost analysis. But I'm not going to show you the dashboards for cost analysis, but they were also created in this 2 weeks period. So basically in the first week, the model was integrated, then model was cut into smaller pieces. So 2,000 elements had to be cut because we wanted to have a proper execution of the elements. Then with the tool, which you can consider as an enhancement of IDS, it was automatically added slightly more than 170,000 classification property items using this data enrichment tool in Bexcel, which is small enhancements to IDS. Then Bexcel, using RFC files, generated almost 1,400 cost items with all proper rules of measurement, and slightly more than 100,000 quantity calculations were done in this initial stage. Bexcel Manager then automatically generated almost 3,000 tasks and 4,000 relationships, and 4 different what-if scenarios were generated, which helped because the main goal was to do the optimization of the construction schedule, which is, as usual, very tight. And by using these what-if scenarios, the result was then duration was optimized for 3.5 months, which is more than 12% of the expected duration. In the second week, almost 1 million schedule-related properties were generated, 15 different custom breakdowns and quantity takeoffs, 6 versions of construction schedule were published on Bexcel CD, and there were 12 Power BI dashboards created. And of course, it was also important to create a lot of videos, because essentially this is the first time in our region, where the project was presented in all mainstream media, so on the news channels and so on, because the project is interesting for the people, and this is the first time we was directly presented in the main news. That's why a lot of these video clips and analysis had to be presented and prepared. So I will now focus on the first week. So the original model was done in Revit, and then this was exported to Excel. So you have two options to have a IFC export or a Revit export, and both options are actually used in this particular project. In the first day, the goal was to evaluate a lot of things which are not optimal. So I will just mention a couple of things. So first one is to automatically check if the elements are correctly distributed to the building levels. And of course, usually not all elements are properly distributed, and Excel has this automated distribution algorithms where you can fine-tune and automatically distribute all the elements to the proper building levels. This is very useful for quantity analysis, for management of subcontractors, and of course for planning phase. You don't want to have wrongly placed elements first because they are not correctly placed in the model. The second goal was to identify all the properties and all the quantifications which already existed. So what helped us in this stage are possibility to automatically calculate geometry-based properties. So even if they do not exist in the authoring tool, Excel has a various advanced mathematical ways how to calculate based on geometry certain properties, and this was heavily used on this project. So a number of additional properties were generated. So if you don't have all the properties, of course, there is always an option that you can add these new properties. The second thing was with the automated data enrichment ability to add various classifications. So just to give you an idea, the system recognizes if the element is, let's say, IFC slab, and the property is it bearing is true. He will, if we are using uniform classification, automatically generate two additional properties, in this case B1010.10 and floor structural frame. This is very open system, so any classification can be used, and so the message is that you don't need to have a perfect model, and yet you can automatically add a number of new properties and use this for cost estimation and planning and later progress monitoring phases. The next thing, which is also very interesting, is that I used to say, although it is not formally IFC 5, but we already want to bring a number of things which will be possible, hopefully, when the final IFC 5 is released. So one of the things is related to what we call the fit for purpose data. So we as users usually don't care how certain things are modeled. And in this particular case, some chairs in a VIP rooms and other parts of the football stadium contained, in this case, each chair more than 227,000 triangles. So this is maybe useful for a perfect rendering of that chair, but extremely not useful for a project of this size. And in this particular project, original design, only chairs without chairs for attendees. They were modeled, let's say, efficiently, but they contained almost 2/3 of all triangles or faces. If it's familiar for you who know a lot about gaming engines and who love to play games, so almost 2/3 of all faces and triangles were for the chairs. Luckily, Bexel has our intelligent mathematical algorithms which tremendously decrease the size of this geometry. Again, they look almost the same, so we as humans cannot notice that tremendous reduction in the triangle. So just to give you an example, that from this number, each chair was, let's say, compressed to around 500 to 600 triangles. It looks still very decent and useful, and we have a huge memory saving and optimization. So this is very important message that for all analysis and for all, let's say, construction management and asset management purposes, we need really not to use original pure IFC files. We need to think always if all this information needs to really be useful on the site. So just to give you an example, I'm a field engineer. I'm about to track the progress. I'm not having a mainframe powerful machine on the site. My internet is not extremely good, and I'm about to track the progress. So why I should load huge, very detailed BIM models for each element if essentially I just want to select if certain chairs are installed on site or not. The same goes with asset management and so on. So we always insist that the fit for purpose has to be done, and in this case we are using intelligent Bexel geometry optimizations, which of course can be fine-tuned, so you can define the level of optimization. So if I want really a slightly better chairs, I can choose 2000 triangles. If I want really very optimized, maybe even with 200 could look quite decent. But of course, this could be fine-tuned, so this part was analyzed with geometry optimization. And luckily, with this, you can have, let's say, extremely detailed model, maybe for some rendering or videos, presentation purposes, but then you can have efficient 3D model, which is used on the site or for a standard regular construction engineer workflows. The next thing is a cutting of elements, and for this purpose was used Revit. So in Revit the elements were cut, but also it's possible to do this in Bexel Manager directly. So both options existed. In this case was chosen to cut the elements in Revit, since original IFC file existed in Revit, and we believe, and I personally believe, it's better to do these things in authoring tool if you have original IFC files. If you do not have files from original authoring tools, or even you don't have IFC files, but some other 3D geometry files and so on, then definitely it's much more easier and streamlined to do all this element cutting in Bexel Manager directly. So in this case, 2000 elements were cut and the landscape model was created. This is also, you will see later in the videos, thing which we strongly suggest, even if designer has not modeled landscaping or excavation, and so on, various activities related to landscaping. This should be added because it tremendously helps so you can understand much better the execution of all your works. After this, the teams sit down together, so 4D planners, project managers, BIM project managers, engineers, and they analyze which options will be and which workflows will be used in order to create a proper analysis. So one first thing was how to distribute of the elements. So, and the system automatically distributed elements to the proper building levels. The second thing was data enrichment, and this is what I mentioned in this particular case. Bexel recognized a certain IFC category or IFC entity, and then automatically, if the certain properties are fulfilled, add new properties automatically to the BIM model. So based on that, Bexel literally attached to almost all elements new properties, in this case Uniform 2010, and description for Uniform 2010 was added and later used in the cost estimation and planning phase. Next thing after that, which took only 2 hours, was to create various based on the templates. You just load various templates, or you can just in a minute create various templates in Bexel. So for various quantifications. So it's not just simple quantification, let's say just for all project, but you can do all these quantifications based on the zone, subzone, based on the subcontractor or main contractor, based on the amount of execution, so you name it. So various quantifications and custom breakdown structures were generated in order to analyze better the model. And what is always very important, especially for planning purposes and quantification purposes, that all the custom breakdown structures for building levels, subzones, main zones, and in this particular project we have 2 leading contractors, so all the works are organized in these groups, and of course you can visually see if this is properly done, and if you want to do any fine-tuning, this can be done easily. Then in the Bexel has a lot of this automated workflows because we believe the time is really essential, and in this particular case, Bexel can use original RFC properties and based on them create and generate cost items. This is very useful feature. So in Bexel you can define that for, let's say, concrete wall, the formula will be volume, or for painting of the wall, the formula will be twice area of the side area, let's say. So you can define what formulas are, and Bexel automatically add these formulas and create the quantification of each of these cost items. So in this case, slightly less than 1,400 cost items were generated. This was original model. Let's say, and this was done in April. So I believe today, of course, model is much more detailed, and we have more than 3,000 cost items on this particular project. How the system works? You load the rules of measurement for a certain market and certain classification. In this case, Uniform 2010 was used, and the standardized rules of measurement for the region was used. So you can see here some formulas, how to measure certain things. So it could be basic formulas like just the number of area or volume, but could be sometimes much more complex, like a surface area, for example, for roads, or a largest projected area and multiplied by thickness for ramps, and so on. So there are a number of ways where you can have more complex formulas for certain elements. And then Excel automatically calculate based on the rules, how the codes are generated, automatically calculate all these cost items and connect them with the BIM models. Then, of course, the prices are defined or can be loaded from predefined templates. In the next stage, it took 4 hours, and this is this huge time saving. So it took just 4 hours to define the project zones and based on to immediately verify if the size of these zones is relatively okay and comparable, and then you can use these zones in Excel intelligent planning edge. So how this works, in Excel you can define various what's called construction methodologies. And in this case, since Excel is used on almost for, let's say, just almost every World Cup from 2014, some football stadiums had Excel on their sites, and we expect now the latest one in Saudi Arabia in 2034. Also, several stadiums are already planned. Also, among the other tools, of course, Excel is used, and because of that, you just load the template for construction, for football stadiums or any other, for high-rise building, for museum, for hospital, for hotel, and so on. And Excel automatically generates the schedule. So there are two parts how this is executed. First is that you load and define relationships between those subzones or zones or building levels. So, and Excel of course knows that it usually goes from down to up. You just need to define the zones if there are certain things are going to be done in parallel or not. And then in a second step, you load the template. And in this case, there is a template, as I mentioned, for stadiums, and you just load it. It basically is very simple thing. Let's say you start with some excavation or project signage, do a lot of things, and usually finish with some furniture or some movable items at the end. And you just, by defining these relationships, Excel will in an intelligent way create thousands of tasks. And if you want to change something, that's how what if scenarios are done. You just change here relationships, or change here that you should wait for a certain thing or do two things in a parallel, and the system automatically regenerates that schedule. So it took just 4 hours because of everything was predefined and used from the previous project. So it took for the planner just 4 hours to slightly fine-tune the methodology used for the previous football stadiums. Because based on that, virtually in a minute, Excel generates the schedule with, in this case, a huge number of tasks and relationships. What is also beneficial, automatically you have a flow line or line of balance, so you can visually see in a flow line when certain activities will happen. And what is also very important, to each element, to each task, all the elements and their respective cost items are attached. So there is no manual process where you need to select a group of elements and attach to the task, which is usually not very interesting and takes so much time and of course prone to the errors. When the schedule is generated, then planners sit down and with the project manager, and usually there are various what-if analysis. So one option was to start from one, let's say, part of the project and go in a clockwise direction, but then based on the analysis, it was concluded that it will take so much time, and so it was decided to have a two parallel set of activities. So immediately after zone 1 start, the zone 4 in parallel will start, and the one crew will be in charge of these 4 zones, and another company for another 4 zones. Of course, if this was not even sufficient, maybe decision will be to create 4 parallel zones and subzones. Of course, then coordination is slightly more challenging, but nevertheless, you will make the project on time. The idea is, of course, whenever you make it literally in a couple of minutes or hour or 2 hours, you can fine-tune this scheduling logic, and the system automatically regenerates everything. So as you know very well, without automation, there is not a proper what-if scenario. So you cannot do this if you have to do it manually, because simply you will then have only usually one option and not the chance to do the analysis. So of course, then, since we knew already there are going to be 2 main contractors, the client attached the information who is going to do what automatically, and this information was shown here in the process, and all optimization of resources were done separately for contractor 1 and contractor 2, because you don't need to have all the activities only optimized but each contractor or subcontractor needs to have optimized activities and quantities for them, because otherwise it simply won't work efficiently. Then in Excel there are a number of additional features, like if you're familiar, of course, with Gantt charts. One of the things which is unique to Excel, you can, let's say, so-called squeeze or extend duration of the master tasks or the parent tasks. So if you want to make duration shorter, you just squeeze the top tasks or the milestones, and then the Excel Intelligent Planning Engine tries to squeeze in a proper way all subtasks to keep relationships and everything else, but to make duration shorter. So this is one way. Then, of course, all the analyses are produced, so you see if this shortened version is realistic or not. But this helps a lot, and again is a huge time saving. Of course, what is another way to do this optimization is that Excel can automatically, based on the predefined the maximum productivity rates, recalculate durations, and of course you can change and adjust this maximum output. So the goal is that from this, let's say, quantities, you have something which looks almost ideal. So Excel distributes that. Let's say you define that, I don't know, 200 cubic meters is a maximum production per day, and then Excel adjusts duration to have this goal fulfilled. The next thing, what was very important, is to do line of balance optimization. So this is really very important, because you would like to see that the activities are not overlapping, and the main goal was to analyze in deep all this, who is doing what, on which building level, in which zone certain activities are happening. And if you notice that certain activities are overlapping, you know that you will have a construction issue and you would like to avoid this. So Excel automatically detects those zones, and based on that you can have more optimal schedules. Another interesting thing is that Excel, by this leveling of resources, automatically calculate, by knowing the quantities in each zone and subzone, sometimes optimal plan looks like this. So it does not need to be a straight line like this one, because simply in a certain zone you have more concrete works or more metal works and so on, and Excel adjusts this so in reality flow lines look like this. Another thing is that you can adjust how the work sequence will be executed. Is it in that direction or that direction? And this is of course important in this case for football stadiums. Radial ordering of the elements were used. Then you define need to move to the production stage, and you need to set up various cameras, temporary works, video editing. So you need really to, based on this initial 4D, 5D simulations, create something more visually attractive. And in this case, since general public was involved, it has to also be in a certain way self-explanatory, because as we all know, most of the people are not familiar with the things I mentioned before. So next thing was that I will just now a bit faster explain several things which were created in the second week. So one thing was that automatically look-ahead plans for each week or each month were generated, so the system can analyze if the quantities are balanced, who will need to do what, and then all the data and respective analysis were published to the cloud, to the, in this case, Excel CDE. So all the things are based on IFC, and all the models and sub-models are based on IFC. What I will mention here, comparing to some other tools, is that we usually, beside having a standard sources, Excel has an option in Excel CD to automatically reorganize IFC files into much smaller chunks. So you can usually, on this particular project, you have 4 different levels. So you have building level, then on the second you have a phase of the project, then sub-phase of the project, and type of the work. So if I'm, for example, tracking the progress just of the structural elements on the first underground level, I can just load that small chunk of the BIM model and track the progress on my tablet on the side. So although it was modeled as a single IFC file, let's say for all structural works, I have the option to just load that small chunk, which is of course much faster and does not require very powerful machines. So in Excel you can define how these structures will be organized, so to have optimal fit for purpose usage. And this is something which is also an idea in IFC 5. So to move from static IFC files to something which is much more dynamic, so you don't need to transfer all information or load all the data at the same time. In the next step, you have also the option to choose which properties are going to be published. It's not shown here, but just to mention, so you, for example, on original files, certain elements, because as you know, I'm as a designer add a certain properties, then my colleague add an additional, then my supervisor add a new properties, then in this case, Revit add a bunch of properties I might need or might not. So in Excel, when you publish the data in CD, you have a lot of templates and just can publish the properties which you really need for certain use cases. So you don't need to publish, in this case, there were, if I was informed correctly, on certain elements, more than 200 properties. So again, we need a lot of time to load all these things, And on the other side, we don't need this. So it's very difficult to find the right property I would like to use. So in order to avoid this, you choose the right optimal set of the properties. We have a lot of templates. You can create your own ones and use only them for a certain use cases. And again, this is something which we all hope will be in IFC 5, so you will dynamically load the properties for a certain use cases or user stories. Then you can publish a selection set, so which are could be intelligent, smart selection sets, or let's say dummy selection sets, and all this you publish to the CD. You can of course publish various quantifications, custom breakdown structures, quantity takeoffs, and various colors. In this case, we had more than 17 million of kilos just for a steel structure. So this all information is published, and then you can publish a various what if various simulations, and just to visually see what if scenarios on the cloud. In this case, 6 simulations in this screen were published to the cloud with all cameras, durations, and so on, and you can run all of this simulation in combination with all other analysis on Bexel CD. At the end was added the Google Earth, so with the neighboring roads, highways, and so on, so you can have understanding where the project is. And what was also important, since this football stadium is part of much larger new development, the additional Expo 2027 project is added, some residential projects neighboring, and in total the value of all these projects is around 2 billion euros. At the end, you define the access rights, who can access the documents, who can access the models, who can change this, who can upload the new versions, and so on. So you set up all these access things, which are very important for the next stage of the project execution. What is also very important, that at the end, the dashboards interactive are automatically created. In this case, 12 dashboards were generated just in these 2 weeks. Everything is luckily to full automation can be done in Bexel in a streamlined way. So in this case, you can see model explorer with basic quantities, area analysis, schedule integrity check, which is based on DCMA, so you check the quality of the construction schedule. In this case, our look ahead plans, quantity analysis, again, some quantifications for concrete works and steel structure and so on. So the beauty of this dashboards is that the findings now of generally the users on the global level is that they prefer and they understand much more the benefits of BIM if they just work in this more interactive way than if they have to do a lot of things manually and need to know a lot about BIM and so on. So what we believe, BIM and digitalization is not just for the experts, it's for everyone, and luckily a lot of top managers are now using these dashboards and on a daily or weekly basis look at them and analyze where the project is, so they don't need to be the experts. What is another benefit is that these dashboards are interactive. You will see in the end results videos how this looks like, so they can do various what if scenarios. Today's situation is they need to ask some BIM manager or expert, then in a week they send them reply with the new analysis and comments. It takes so much time, and they can now do by themselves certain things. Now they can, the thing with the dashboard is that now it's much more democratized, so they can, everybody has ability to do all this analysis by themselves. And now all these dashboards are added in Excel, and of course with the proper access rights is defined who can see what dashboards or analysis. And at the end, last thing was, I think it is Camtasia or some another tool. So video editing, so based on all these interactive videos, and since it was a very important project, it took 2 days to video production specialists and project manager, even some marketing advisors for let's say people in ministries were involved, because all they wanted to have a nice and proper presentation of this project. Then in the last day, Project Expo 2027 and the neighboring roads, pipes and so on were added, because this was already developed in the previous stage, so were added to put together in the combined video analysis and simulations. So I will now, so you have here, I believe this presentation is accessible on the standard location where all presentations from the summit will be presented, but so you will have ability to go directly to the video on the YouTube. I will now just switch and show you the video, how the stadium, just this end video which was presented in this public medias, in the main news. So this is a 4D, 5D simulation. The project should be finished by the end of 2026. So it's a very tight schedule, having in mind that more than 1,400 piles are there. Some of them are almost 30 meters, because it is a sand. In the past, this was a swamp. So this is why it will take a lot of time, and 30 months as a deadline is quite tight. So as you can see, everything is produced according to the defined plans and so on. And if it was done manually, it will take months just to do this simulation. But luckily, to this intelligent automated processes, this was possible to be done in a very efficient way. Since I'm now streaming from my laptop, if this is not decent, you can go to the YouTube and see how the video looks with an excellent frame rate. Because all these two projects are correlated, and this football stadium should be open before Expo will start in the beginning of 2027. All this has to be coordinated and considered as a same project, as a single big project, and is actually managed by the National Building Directorate. So they coordinate all these activities together. So these are now very basic things. So when you set up different cameras, you can visually see how the things should be done, what is the order of the activities, with the different colors. In this case, we see different activities, but if you just switch to the zones, now I can see 6 major zones used on the stadium. So visually can see in a different ways when certain things will happen. What is also important now, I see sub-zones and so on. But what is very important to mention here is the additional information which are produced in the dashboards. So this is a standard, let's say, 4D, 5D simulation stored on Excel CD Cloud. But what is the beautiful thing is that beside these simulations, in this case, on the left-hand side, I see that 112,000 cubic meters is just stored in the elements which I visually see at the moment. And I can easily filter these elements and see only the parts of the stadium I'm interested at the moment. There, you can, of course, have this integration with the floor plans, various documents, and so on. But I will show you this in a couple of minutes, how actual communication on the site works. So if you identify steel structure, I can see how it works. I can see, of course, a Gantt chart, a flow line chart. So all this, and this is very important, look ahead plan. So I will just stop here for a second. So just to show you, so in each, just for that part of the project, which is now isolated, so ground floor and only concrete works on a football stadium, I can see literally on a weekly basis the amount of work, in this case on a daily basis, amount of the work per day. And so you see the works are very intensive, so literally we have to put around 400 cubic meters per day, which is not so easy, but you can see with the different colors and different uniformed codes who should do what and when. And whenever you filter each part of the project, you see this analysis. And this is very helpful, especially in the construction execution phase. So now this thing goes for the just part of the project. So now I'm not isolating the works per building level, but per zone. And again, if this is supposed to be done by one subcontractor, I can see all analysis just for that. These are piles and pile caps. This is a steel structure, so how many tons of steel has to be installed. And then, of course, I can again see this nice 4D, 5D simulations, so I can see how the works has to be installed on the site. And all this, when it's finished, is sent to the contractors, and they look at this before works commence. So I will now just move so I will now continue with the presentation. And what was very important, now the communication when the execution of the work started. So in this case, we are using Bexel BCF server and Bexel BCF client. Everything is based on openBCF standard. So if you want, you can have another client which is developed based on openBCF client standard and use it. So Bexel has slightly enhanced features comparing to standard openBCF because for our clients it's very important to have fully integrated document management system, and so we natively allow to attach various documents or version of the documents in our communications on the BCF. And you have various additional workflows like document approvals, multi-level document approvals, automated copying from, let's say, work in progress to published sections of the document system, and so on. But again, everything, and we strongly encourage all developers to use openBCF standards because this allows us to easily switch from one application to another, or if someone is using a client which is not developed by us, they can by themselves develop, I don't know, a client for, let's say, ArchiCAD or Tekla for a certain clients. We developed BCF clients, but everybody can develop their own clients if they want and connect the data with, in this case, BCF Bexel BCF server. Of course, any other BCF server can be used as well. So in this case, I will show you a short video where on a Bexel CD, we have used, of course, Bexel CD Cloud, but also Bexel BCF Server and Bexel Docs. And the workflow we will describe in this short video, the following workflow will be presented. So the planner sends the look-ahead plan to the field engineer. Field engineer has a question that certain drawings are not updated, so he asks a design manager to update the new drawings for certain things. Then drawings are submitted by design manager to project manager. Project manager approves documents, and they are then automatically sent to the field engineer. So field engineer knows what has to be executed on the site. Visually, you can see look-ahead plan, but also have all accompanying documents necessary for proper execution. Then works are executed on the site. Field engineer enter the actual progress, submit this to the supervisor. Supervisor reviews and approves or approve with a comment. This works. Update, the progress is automatically updated in Bexel Manager, and planner creates a new updated progress which includes a baseline schedule, an actual schedule, and then their reports are automatically published and submitted to project management team so they can review the works on the site, and it's done on the weekly basis. Could be also on a daily basis, could be on the monthly, but in this case, the client decided that the weekly interval is the optimal for them. So I will now just, again, this video is available on the YouTube link, but I will now switch and show you in live how this workflow works. So in this case, this is Bexel CD ecosystem. You can see various models, scenes or floor plans. This is a BCF communication, all the properties. As you can see, everything is based on openBCF standard, but there are some additions like interactive documents and certain things which still does not exist in the openBCF standard. And here are look-ahead plans for each group of activities. So now this is isolated by the planner, and he is creating the new BCF and codes and who has to do this. So in this case, Power China is the main contractor, one of the largest companies, construction companies in the world, and the information is sent to the field engineer, but he sent reply, I need some drawings to be updated. So he wants this information. The good thing is that this is entire history. And for example, in some countries, in Croatia or a number of other countries, this is actually for any potential dispute could be very important, that you have entire history, who sent when, what. And by having this history, everybody is really focusing on efficient work. So not you didn't send me the data or this or that. Everything is very transparent, and it really helps that everybody starts to be focused on efficiency. Not they are working more as a team, not as enemies on the side. So now when the field engineer sends this request, design manager is invited to upload a new version of the document to the site. You see all entire history of the previous versions. You know when this was updated. So if the works are wrongly executed, you know if the contractor already had this information or not. And now design manager starts the document approval workflow. I will just stop here. It is based on BCF, but still openBCF does not support this, so it is still in Bexel, then on Bexel side, but we hope that these document approvals and other workflows will be also enhanced in openBCF. So everything which is available in BCF is used by Bexel, but there are certain things which simply does not exist at the moment in Open Standard. So this is now created as a document approval. Emails, notifications are automatically sent to the project manager, and all comments, histories, questions are there, and now project manager must approve a new version of the drawings, and this is how this process of approval works. This is now a look-ahead plan and what field engineer looks. So he sees exactly what he has to do in that week, and he, for example, is a big delay, and he deselect just the elements which are not done in the planned week. He can, of course, add the works from the future if he wants. In this case, it is based on the elements, but for some activities, we have also on this project a workflow where you have a different selection of elements for just concrete, pouring activity, and the different form work. So you can define how you will do this. What is also important is that with this information, at the moment it is not used yet, but we are now working with several tools, testing them, which automatically, based on the drawn 360 photos, detect the executed works, and we hope maybe on the next summit we will be able to show you how this works with the real drones. At the moment, existing tools are still not reliable, so there are a lot of mistakes, wrongly recognized elements, and that's why we still believe humans should these progress entries. So this, just basically deselect what's not done and send this as a request to the supervisor. So he needs now to verify if these works are done. But it is very transparent, it's very open, everybody can visually see what they can have to review, so entire communication is there. So he now basically asks supervisor to verify if this is okay. And this is now how supervisor can work on a laptop or on a tablet. He sees the works and can reduce against certain things, send comments, or send just the photos from the site where he, for example, confirms that these works are actually done. So again, entire history is there, so everybody knows what was recognized, when this was recognized. There are no disputes if this was okay or not, or wrongly understood. And this is now, this is in a Bexel manager. Now how BCF client. So again, this was a BCF server on the server side, and now on the client side, in a Bexel manager or any other tool like Revit, ArchiCAD, Navisworks, and so on, you see the same panel and the entire history. So now the planner, based on the confirmed works by supervisor, automatically creates a selection set of these elements, and the system also automatically creates the quantities. So when you load the elements from the site which are executed, Bexel automatically calculates the quantities. So now literally for each phase, each sub-phase of the project, you see all the quantities. So you have a very reliable information. It's not done manually, which causes a lack of trust, but also huge inaccuracy and inefficiency. So now this is automatically calculated and generated for monthly payment certificate, and Bexel can also update the project, and you will have now notice that certain delays occurred. So this is now a straightforward process where you publish to the dashboard, and then you can, in an interactive way, see planned versus actual, so the cumulative curves, actual works, and you can filter all this based on a various analysis. In this case, planned versus actual is, for example, blue colors usually means that this is executed on the site, but with a certain delays, and delays. And red colors represent the elements which must be, and orange as well, and yellow, which must be executed so far, but are not. And we actually see if it's 2 days, 5 days, 15 days, and so on. So these are the ways how you can visually see the situation. You can go back in the past, see how it looked like, let's say, on a 7th September this year. So, and of course, the colors are changing interactively. You can filter for just, let's say, cubic meters of concrete works, and now you can see literally that we are even slightly ahead of schedule, so cumulative actual quantity is slightly higher than it was originally planned. But some activities are delayed in this orange part. Luckily, a lot of green ones are there, which are ahead of schedule or as planned. So this is just one of the dashboards. And of course, this is used directly by project manager, and by various filtering, you can see where delays are happening, who is in charge of this. You can filter per subcontractor, per type of the activity, per zone of the project, and you name it. So it's very interactive, and instead of publishing 1,000-page document with PDF, which usually nobody will read, now you have everything interactive, and everything is clear. And feedback, I have to say now, is that more or less everybody is satisfied, because a lack of trust is one of the biggest challenges on construction projects. So that's more or less everything I wanted to present. Do you have any questions?
Hello, welcome. Can you hear me?
Yes, I can hear you.
Thank you. Thanks for the presentation. I have some questions, but okay. One important one is in the planification or the simulation, sorry, of the schedules where you generate the different schedules. Okay, you have sorry, if you know, when you have a schedule optimization, I think it's in that part for the planner. And you simulate different types of construction, let's say machinery, for example. I don't know if you use different cranes, or if you have the different type of equipment that sometimes the construction company is evaluating what would be better if they use certain equipment or any other construction method. Is that also in the solution?
Yes, so thank you very much for your question. Definitely, when you analyze the construction schedules, equipment is also attached to the activities. So whenever you run a simulation, you can see a chart, for example, how many cranes are used based on previous statistics and production rates on the site. And the message might be 8 cranes will be used, or 6 cranes, or 4 cranes, and so on. So this is the way you can have the similar thing with the trucks. So You can analyze how many tracks has to go on a daily or hourly basis to the site. So you have a real information based on the productivities. Of course, I can say only for the major things these analyses are done, like for concrete works, steel works, facade works, and so on. The rest of the project is more generalized. You don't have a productivity for each small wall, but again, for mechanical work, you can say per kilo, how many kilos you will install of mechanical, and based on that have a certain estimation.
Do you have any questions? So, yeah, thank you very much. Can hear me?
Thank you, Ken.
Yeah, and I guess here's some people, but I guess some of them here their story with the manager the first time. So I'd like to ask you how the main module of the big cell. Because you said you mentioned big cell CD and then the big cell IFC manager and some other some simulation or 4D or 5D study. But how's the mainstream of the using the your system is what we want to hear from.
Sorry, can you repeat, Ken, the last part of the question?
Yeah, so we need to know the very brief system architecture of your system. Can we?
If you ask about the architecture of the system, so basically Bexel Manager is the main intelligent integrated system for engineering analysis. It is let's say optimal planning, intelligent planning, cost estimations are done in a Bexel Manager, and it's usually used by slightly more experienced engineers and professionals. Bexel CD on the another side is much more for all project stakeholders. So for designers, field engineers, planners, they can see project managers, top managers, they can see end results and interact with dashboards and easily communicate in the cloud base. So you have a combination of expert tools, let's say, but it's not necessarily for experts, but some definitely slightly more experienced, and then much broader audience who is using for document management, BCFs, communications, progress monitoring, and so on, or asset management and so on. So is this answer to your question? I couldn't again. Okay.
So what you mentioned is for site manager or some the company working with in the site. They use the CTE for class detection and then some kind of work in progress document sharing. I guess your Excel manager is very integrated. It is used for analysis. So all the published data should be uploaded to the Excel manager. But some BIM model, which is in work in progress, should be under some other CD. Is my understanding. How about the reality to manage the data?
Sorry, how about which?
So, give me.
So just if I may say, if you asked, maybe internet is not so good, but you can, if you ask about the tools on the side, In Bexel CD, you have a lot of accompanying information like the different colors, communication history, and so on. But why we always believe open BIM standards has to be used, because even if you do not have Bexel CD on the side, but use any other 3D tool, which support BCF, you can simply save the actual progress on site and send and upload to the central server. So you don't need to use Bexel only on the site. So this is, of course, what we all believe is the future, where we will more democratize the usage of the tools and technologies.
Okay, so it depends on the title of or the role of the construction, and then some data should be managed by manager or the owner, and then it must be shared by some very detailed dashboard. But all those data might not be shared in the site normal user. So it depends on authorization and authentication, and then divide the data visibility is your system.
Yeah, so we really believe, Ken, thank you for asking this. We really believe that the optimal amount of data must be used. Well, I'm not a big fan when I see, as I mentioned in the presentation, million of elements, each containing 200 properties, and with inefficient geometry, and everything has to be loaded on a field on the site. Since it works very slow, and you know that a lot of times it happens that it's very difficult to load this information. On the other side, if you have a fit-for-purpose data, first benefit is access rights. So I might not see, I don't know, there is a new unique technology used on the site, and maybe only designer or part of design team can see all the properties and specifications of this equipment. But I'm a field engineer, I'm just tracking the progress of structural works. Why I should have access to this? And on the other side, why it's much easier for me if I just track the progress by visually seeing the elements I should see and load. And only the property is important for me. And I really hope that this is the vision. I talked with Greg Schulzauer a lot in Valencia, and I know now we have discussion in Marrakesh again about IFC 5. So this is really the idea of IFC 5, to have more fragmented data and data access, and load only the data you really need for a certain use case.
Oh, I see. Yeah, I want to look much more detail, but it's time running. So But anyhow, thank you very much for your answer. Thank you.
Thank you, Ken. Thank you, Jorge. Are there any other questions?
Okay. Yeah.
So, thank you very much all. Have a great time in Marrakesh, and see you tomorrow at Roundtable.
Bye-bye. Thank you very much.